The goal is to compute the following indefinite integral. We see that we have a rational function where the degree of the numerator is greater than the degree of the denominator, which means that the first step is the long division of x to the power 4 by x3 minus 8, which gives, and therefore our integral I becomes the integral of x dx plus the integral of 8x over x to the power 3 minus 8 dx. Now let's call this integral j, and let's write the partial fraction decomposition of the rational function 8x over x to the power 3 minus 8. So the first step is to completely factor the denominator x to the power 3 minus 8, where we can use this identity. It follows that the partial fraction decomposition of this rational function, let's call it f of x, is, note here that this quadratic function is irreducible because its discriminant is negative, which gives this form of the partial fraction decomposition. Now, as you know, there are many approaches to compute the real numbers a, b, and c. So let's start with a. For example, to compute a, we can multiply both sides of this identity by x minus 2, then simplify and evaluate at x equals 2. So multiplying by x minus 2 and simplifying gives, now for x equals 2, this term here will vanish and we will have a equals 16 over 12 or 4/3. Now to compute c, we can evaluate both sides of this identity at x equals 0, which gives, finally, to compute b, we can evaluate both sides of this identity at any value except x equals 0 and x equals 2. Let's choose, for example, x equals 1, and this will give. Finally, we have the partial fraction decomposition of our rational function f, and then we can split the integral j into the following two integrals. The first part is straightforward, and let's call the second part k. Now to compute this integral k, we perform some algebraic operations so that the derivative of the denominator x squared plus 2x plus 4, which is 2x plus 2, appears somehow in the numerator. Now this can be done by simply multiplying here the numerator and denominator with 2, and then by writing negative 4 as 2 minus 6. So we can see here that we have a function of the form g prime of x over g of x, whose integral will give a natural logarithm, and the integral of the second function will give a tan inverse. After writing k as a combination of these two integrals, we know that the first integral is ln of the absolute value of x squared plus 2x plus 4, which is positive because the discriminant is negative and the coefficient of x squared is positive, which means that this quadratic function is always strictly positive, minus 3 times the second integral. So we know that by completing the square in the denominator and by using a convenient substitution, we will have a tan inverse function. Now we can see that in this integral, the convenient substitution is u equals x plus 1 over square root of 3. Finally, putting this together will give us the integral j, and then the integral I, which was x squared over 2 plus the integral j.